This is my third video for limits. I have shown 32 questions last two videos. Here I will show more problems on limits, advanced level combined maths, pure maths section, revision on limits. So the next question, problem 33. Third root of 1 plus x minus third root of 1 minus x completely divide by x. What is the answer? If we directly substitute x for 0, what happened? This is 1 minus also 1, 1 minus 1 0 over here 0, 0 over 0, one of the indeterminate form. Here we will solve any other method. So what happens if I use the algebraic limit theory? This can be shown 1 plus x power 1/3 minus 1 minus x power 1/3. Okay, then below without the power, x to the power n minus a to the power n over x minus a, x tends to 0. Therefore here without the power, we'll check that 1 plus x minus 1 minus x. So in this case actually x is 0. So otherwise we can say 1 plus x tends to 1 minus x. Okay, that's also true, right? 1 plus x tends to 1 minus x. Otherwise x tends to 0. No, both same idea, meaning. So is it correct? Numerator is okay. See below 1 minus 1 cancel. 1 minus 1 cancel. X minus minus 2x therefore. But actually in the problem 1x. So 2 is an additional term. So remove that. Can I multiply by 2 here? Multiply by 2 there. Okay. Therefore, here write the answer. X to the power n minus a to the power n pattern. So what the answer? 1/3. That's 1 minus x to the power deduct. 1/3 minus 1. Okay, n a to the power n minus 1 form. Those are newcomers, so best thing is stop this video, follow, complete the video number 1 and number 2. Hence come to this, then you will feel very clearly of this limit revision. And there's a 2 here, right? So now actually x tends to 0. X tends to 0. Or like this we call here. Put x for 0. The answer is what? 1/3 into 1 to the power minus 2/3 into 2. So simplify. That's the answer of this 2/3. Answer is 1 to the power anything is that is 1. The answer is 2/3. This I gave last class a homework. I hope you complete successfully. Then you can see this method. Algebraic limit. Question number 33. Next problem 34. Question 34. Limit x tends to a square root x minus b minus a minus b square root over x square minus a square. Is it? So I hope you have done this problem earlier. I gave last second video. Question number 34. Where a is more than b, that means a is greater than b, right? The condition is available. So what happens if we substitute straightly x for a? Here a minus b 0 over 0. You can't determine. That is one of the indeterminate form or meaningless form. Therefore, use that irrational value, rationalize the part. The numerator should be rationalized here. Such a problem, the idea you multiple up and down on numerator, denominator by the conjugate of that. So limit x tends to a square root x minus b minus a minus b. This also can be factorized, x square minus a square. That is x minus a into x plus a. So here with I multiple the conjugate of the numerator. So what is that? X minus b plus a minus b over square root of x minus b plus a minus b. Okay. So wherever we use the conjugate pattern become a factorization. So limit x tends to a, you can see the factorization a minus b, a plus b form, that is a square minus b square. Therefore that is x minus b, we square root out vanishes, minus a minus b, okay, that over x minus a, x plus a into this one 1 over square root x minus b plus square root a minus b. Okay. So therefore limit x tends to approach to a. See what happened here, minus b plus b cancel, x minus a available, below also x minus a cancel, right? There are 1 over x minus a cancel. So remaining part x plus a and the square root x minus b square root a minus b. So I hope you have already done this problem as homework I gave last second video. So put x for a now. The answer is 1 over, put x for a plus a 2a within that bracket, put x for a minus b square root, again a minus b, so 2 times square root a minus b, right? Therefore the answer 1 over 2 times 2, 4, and the remaining square root part, right? 4a into a minus b is the final value if you use that pattern, multiplying the conjugates, right? This is my question 35. See, next also I said last class I gave that question. Problem 35. It is question 35th problem. It is third root 1 plus x square minus 1 over x square. Okay, another third pattern. So if you, the limit is x tends to a, right? Limit x tends to 0, So what happens if you put x for 0 here, 1 minus 1, 0, over 0, meaningless pattern. They have used any other mode to simplify, but the limit exists value. So here also we can use an algebraic rule. If we apply this, I write the x to the power n minus a to the power n over x minus a. So limit x tends to 0, here 1 plus x square to the power 1/3 minus 1 also we write as 1/3, right? That pattern x to the power n minus a to the power n. Then below x minus a, 1 plus x square minus 1. Now check whether it's correct. The given problem is okay. The above is okay. Numerator is okay. 1/3 means third root here. And see here 1 cancel. Remaining x square available. So everything clearly here. Therefore write straightly the rule x to the power n minus a to the power n over x minus a is what? N a to the power n minus 1. So here, okay, this n a to the power, that is minus 2/3, is it? Therefore the answer is 1/3. Okay, answer is 1/3. That's the answer. The simple method. Or otherwise another method you can work like this. You can mark this as a u cube. If you take u cube equal 1 plus x square. Another substitute, you can try this u cube. Put this u cube, then completely change the problem in terms of u. See, the same answer comes, right? See, next question, 36. Problem 36, limit x tends to 0, square root 1 plus 1 over x square minus square root 1 minus 1 over x square. Simplify or using the find the limit. So always you first to decide what happens, try substitute. Put x for 0, then both square root is comes 1, 1 minus 1, 0. There's infinity still. If you put x for 0 here infinity. 1 plus infinity, infinity. Here also infinity. So I give very first video, there are 7 meaningless pattern. Check that, one of them meaningless pattern. Not only 0 over 0, not only infinity over infinity, and remaining 5 there, one of that is infinity minus infinity also, one of the meaningless pattern. Therefore use any other method. So you also once again square root pattern. So you remove the square root by multiplying the conjugate. So here minus its conjugate, make a positive, multiple up and down. So limit x approach to 0, square root 1 plus 1 over x square minus square root 1 minus 1 over x square over square root 1 plus 1 over x square plus square root 1 minus 1 over x square. So you multiply above and below by that conjugate. 1 plus 1 over x square plus square root 1 minus 1 over x square. Now simplify. Whenever I use this conjugate pattern, always we work many problem now. Factorization pattern, a minus b, a plus b, therefore there is square root, no square root now is minus that, a square minus b square, that is 1 plus 1 over x square minus 1 minus 1 over x square over this one, right? Square root 1 plus 1 over x square plus square root 1 plus 1 over x square. Here limit x tends to 0. Limit x tends to 0. Then what happened? Numerator, see 1 cancel. That is 2 over x square, is it? 2 over x square. 1 cancel, 2 over x square. And can I write this pattern 1 over this 1 plus 1 over x square plus 1 plus 1 is minus, no? Two square roots remaining here. Okay, limit x tends to 0. Limit x tends to 0. So now we can apply x for 0. What happened here? As I mentioned here, infinity, here 0. Okay, it's completely infinity. 2 over infinity is the answer is 0. Answer is 0. Answer is 0. This is infinity. So a number divided by infinity. Answer is 0. Okay. 2 over x square. That is that. So we can take the x square inside the square root also. Become x to the power 4. There also x to the power 4. You multiply the bracket form also. Anyhow, the answer 2 over infinity. Therefore, answer can be 0 or answer can be infinity. The problem is 0 over 0 meaningless. Infinity over infinity meaningless. Okay, this is the question. Answer. Next question 37. Problem 37 says limit x approach to 1, x square minus square root x over square root x minus 1. Find the limit value when x tends to 1, x approach to 1. So if we put x for 1, what happened? 1 minus 1, 0. Below also 0. Then use any other method of simplification. Here see we have the both numerator, denominator, both in the square root pattern or third form. Both are negative. So in this case, as I shown many in the previous videos, multiple the numerator and denominator of both of their conjugates. Then you can get the answer. So limit x tends to 1, x approach to 1, x square minus square root x over square root x minus 1. Then you multiply above x square plus square root x. Okay, it's conjugate numerator and denominator multiple over x square plus square root x. One part multiplication. Also the other, what is denominator? Its conjugate multiple square root x plus 1 over square root x plus 1. Okay, multiplying numerator and denominator by the conjugates of each. Then what happened? Limit x approach to 1. So wherever you multiply by a conjugates, it becomes a factorization. See this 2, a minus b, a plus b pattern. X square minus root x, x square plus root x. So what the answer is? square minus b square. That is x to the power 4 minus x. Square root x square is x. Okay. And there square root x plus 1. And see here what happened. First and the last factorization pattern. root x minus 1, root x plus 1. That is a square minus b square form, right? And the remaining x square plus square root x. So if we apply once again, put x for 1, 1 minus 1, 0. Here 1, 1, 2, above is 0. Check below also 0. 0 over 0, meaningless. So further you can factorize hereafter. Here take the x out. Here take the x out. Take the x out. What happened? The remaining x cube minus 1, right? And here root x plus 1. This also can be factorized. X square minus 1, your favorite primary work. X minus 1, x plus 1, and x square plus square root x. Okay, therefore remaining limit x approach to 1, x approach to 1. This also you can factorize. A cube minus b cube pattern. A cube minus b cube. A minus b, one factor. A square plus ab plus b square, right? Therefore that is x into x minus 1. The remaining x square plus, multiply the both, 1 times x plus 1 square. And here square root x plus 1 over x minus 1, x plus 1, and x square plus square root x. Okay. Now see, this is cancelled. Now no matter you have answer because all are positive. Negative is the problem because 1 minus 1, 0, 0 over 0, difficult, meaningless pattern. Now it's all are positive terms. Now I apply x for 1. So what the answer if we apply x for 1? Here 1, 1, 1, 1, 3, 1 and 1, 2, 1 plus 1, 2, here 2. So what the answer? 2 cancel, 3 over 2. Is it? Answer 3 over 2. Is it okay to check that? Is it okay? Put x for 1. 1, 1, 1, 3. 1 plus 1, 2. Here 1 plus 1, 2. 1 plus 1, 2. So 2 cancel, 3 over 2, right? Answer is 3 over 2. If you factorize and simplifying, okay, check step item. This is problem. This multiple factorized form. X minus root x minus 1, root x plus 1. That is, I miss x minus 1. I hope you completed successfully. Check that. X minus 1, x minus 1. Okay, x minus 1. And here no x plus 1, right? No x plus, the others okay. No x plus 1, therefore the answer is 3. Check that, answer is 3, right? Answer is 3. Answer is 3. I made a mistake, I put additionally x square, not x square. Root x square is x. Answer is 3, okay. See next question number 38. Question number 38 is sine alpha to the power n, sine alpha to the power n over sine alpha completely power n, completely power n, where that alpha tends to 0, limit alpha tends to 0. Alpha approach to 0. Check how this question. Trigonometric limit. The numerator only alpha has the power n, but denominator completely the power m, right? So we have only one trigonometric limit called sine theta over theta. Sine theta over theta pattern. Sine theta over theta is 1. So we can convert that form and write that. So it's equal, can I write this one? Limit x tends to 0 sine, the angle is alpha to the power n. The angle is alpha to the power n. Therefore, below the same sine theta over theta pattern. Okay, that one. Sine theta over theta. Okay. And here 1 over. This is sine alpha. Sine alpha. Complete the power. You can write below also alpha. And I say completely power is m. Because sine theta over theta pattern, sine alpha over alpha pattern. Now check whether it's correct. Sine alpha is okay. Alpha to the power m, an additional part. It's additional part, right? To remove that, and I mark here 1 over alpha to the power m. This is no doubts okay. This and this. Now see here also alpha to the power n additional part. In the original problem there is no alpha to the power n. So remove that. I will multiple here alpha to the power n. Okay. So these two cancel, remaining available, and these two cancel, complete is available. Therefore the answer here alpha. Alpha tends to 0, right? Alpha to the power n. This is sine theta over theta pattern. Answer is 1. Here 1 over sine alpha over alpha. Answer is 1. 1 to the power m is 1. And here 1 over alpha to the power m. Here we can do this answer totally what? Alpha to the power n minus m. And the bases are same. Subtract the power when you divide the parts. This is the answer. Next question number 39. Problem 39. Limit x approach to 0 to sine inverse x over 3x. As I mentioned the very first day class, there's that video. There's no e to the power direct, that straight problem in exams. National level papers you can't see. And logarithm, no, that's those not in syllabus. Some indirect questions available, I will show in the future problems videos. Also, there's no question inverse functions. Inverse videos, no. No, in the syllabus, if you see all the past nearly 50 from 2000 combined maths or before that also, there's no any inverse problems. So if comes so, we have some idea to remove the inverse part, back convert to our ordinary syllabus pattern, and you can complete the answer, become a determinate form. Okay, see this similar, x is 0, you know sine inverse naught. Sine inverse naught is naught. So below also naught over naught, one of the meaningless pattern, right? Therefore, how to remove this part to get the answer. So I use a substitute form here. I take sine inverse x as theta, right? So let sine inverse x equal to theta. Therefore, the complete problem to be changed into theta form. Completely changed to theta. First limit change. Therefore, when x tends to 0, what happened when x tends to 0? When x tends to 0, theta also, sine inverse 0, 0, right? Theta tends to 0. Therefore, the question is limit x tends to 0 means theta tends to 0. And here 2 sine inverse x is theta over 3 x forward. Sine inverse x theta, what is x equal? Sine theta. x equals sine theta. Okay, x equals sine theta. Thereby I show here limit theta approach to 0, 2/3. This I can show as a standard form 1/sine theta over theta. That's the standard form. We don't use the theta over sine, both same, no problem. But actual method, not theta over sine theta. Sine theta over theta approach to 1, that theta becomes 0. Therefore, the answer is 2/3. Sine theta over theta is 1, therefore totally 1. So answer 2/3. Answer 2/3 is the answer. Therefore, this is the idea. When the inverse comes, you will change some theta form and you can go through the ordinary pattern. Next question 40. It's my third video. Those are newcomers, better subscribe this. Then you'll continuously can be joined with my video series. I have completed vectors, is a limit, and I start the for juniors remind the theorem problem of polynomial questions, and I publish some model paper discussions also. Because it is limit x tends to 0, 2x minus sine inverse x over 2x plus tan inverse x. See, same idea, but the answer. Therefore, you know this case, sine theta over theta is 1. Same can use for what? Sine inverse x over x also becomes 1. Sine inverse x over x also 1, right? Sine theta over theta is 1. Similar, sine inverse x over x also 1. Tan theta over tan theta is 1. Tan theta over theta is 1. Therefore, similar fashion, tan inverse theta over theta also becomes 1. But I proved this, not I straightly used. Similar idea comes here. I show the method from the first principle method. If you directly apply what happened, you know, sine inverse naught is naught, cos inverse naught is naught, therefore your naught over naught case, right? Okay, so very first I divide by x, numerator denominator divide by x. Limit x approach to 0, here 2 minus divide by x, x cancel there, here x divide by x, right, over 2 plus tan inverse over x. So as I mentioned, sine inverse x is 1, tan inverse x over x also 1. But I show if in problem, if you feel difficulty, if you say how it's possible, I will show that like earlier question and come to the answer. So I said it's a completely fraction form limit. So this can, there are some limit properties in the very basic class. We done the class. I hope you learn in the theory classes. Basically, limit comes as a fraction. You have to apply the limit for the numerator, also denominator, right? See that limit x tends to 0, 2 minus sine inverse x over x over limit x tends to 0, 2 plus tan inverse x. So here I am showing from the first principle method, right? Now I take, let sine inverse x equal to alpha. Sine inverse x I take as alpha. Therefore, what is sine alpha is x. Sine alpha is x. When x tends to 0, alpha also 0. alpha tends to 0. Okay. What about tan x? You can work if sine alpha is x. What is sine alpha x mean? Tan alpha square root over 1 minus x square like Pythagoras. That is too long. So I use, like again I take let tan inverse x is beta. Tan inverse x as beta. Therefore, tan beta equal to x. So x approach to 0, beta also 0. Okay, so additional part I am showing. Therefore, come to the problem. Therefore, limit 2 minus sine inverse x is alpha over sine alpha. Okay. Here alpha approach to 0 over, what is that here, limit beta tends to 0, that is a 2 plus, that is 2, okay, beta over tan beta. Then we can use the right answer as I mentioned in the previous question. The answer is 2 minus sine alpha over alpha pattern. Answer is 1. 2 plus tan beta over beta pattern. Answer is 1. Therefore 1 over 3 is it? Check that. Answer is 1 over 3. Okay, that's the problem. So I clearly shown from the first principle method. So everything has a rule. You apply the rule clearly, then only full marks. Okay, next question 41. So you practice this, the seniors, you practice those preparing for this year exam. Practice this, then you have a speed also how to work within a short time duration and get the full marks too. Because one of the question in the structure paper, 25 marks question, it's become easy ideas, simplify. If it's straightly applied, become one of the meaningless pattern. You have to rearrange to any other vectorization or standard limit theorem or trigonometric conversions. Question 41. Limit x approach to 0, 1 minus cos cube x over x sine 2x over x sine 2x. See what happens if we apply directly x for 0. It becomes cos node is 1. Cos node is 1, therefore one of the meaningless pattern. Numerator 0, denominator 0. There were no chance of simplifying that. Then we convert to any other form and complete the rest. So you know that, can I factorize the numerator? A cube minus b cube pattern. A cube minus b cube form. Limit x approach to 0. X approach to 0. 1 minus cos x. Okay. Over 1 plus cos x. Plus cos square x. Okay, this is not limit theorem, this is that what factorization idea, right? A cube minus b cube pattern. Now over for sine we have a limit theorem, no, therefore I'll keep as it is. So x sine 2x. Okay, next part hereafter. Can I change the double angle cos 2 theta? You know cos 2 theta. Cos 2 theta is 1 minus 2 sine square theta. Cos 2 theta equal 1 minus 2 sine square theta. Therefore, you can rearrange for this double angle part. 1 minus cos is what? 2 sine square 1x. Here x means x by 2, right? Therefore, limit x approach to 0. This is what? 2 sine square x by 2. 2 sine square x by 2. And here 1 plus cos x plus cos square x over x into sine 2x, right? So the remaining part in the problem. Okay, now we rearrange the general pattern, sine theta over theta form, right? So therefore, limit x approach to 0, what is that? 2, the sine x by 2, okay? Sine x by 2, then you need below x by 2, okay? But here sine square, therefore I put the square. And here 1 plus cos x plus cos square x, there is no problem, cos no problem. Here write the sine 2 theta, then below theta, 2 theta. So sine 2x over 2x, okay? So I convert all these part into a standard form of the limit sine theta over theta pattern. Now check whether it's correct. Now we'll check. Sine square x by 2 available, okay? Sine 2x available. What happened here? X square, see here x square. There's no x square in the problem. But see here x, very important. So x square, here x, 1x cancel, this x available. No problem about that x. Next one, here 4. See here 4. Is it here completely 4? Here 4. Here 4 there. Okay, is that? Here 2 additional 2 there. You can take this 2 is this 2. You can take a fraction below another fraction, mean the denominator goes up. Okay, so this 2, let's shape. So what happened? Additional part. Here there's a 4. There's no 4 in the problem. Remove that 4. Can write that 1 over 4. Recheck it properly. See there is correct. Here 1 over 4, everything is okay, right? Sine 2x available, sine square x by 2 available, the 2 available, x square, here x cancel. So what the answer is 1 over 4, sine theta over theta answer is 1. Here put x for naught 1, cos naught is 1, cos naught is 1, below sine theta over theta is 1. So what the answer is? 3 over 4. Check important part. 3 over 4. The answer is 3 over 4. Next question 42. Limit x tends to pi by 3, 3 minus 4 sine square x over 2 cos x minus 1. 2 cos x minus 1. The limit approach to pi by 3. So what is sine 60 root 3 by 2? Root 3 by 2. Is it sine 60 root 3 by 2? So here 3 over 4 cancel 0. Cos 60 half 0 over 0. One of the meaningless pattern. Therefore you try to use any other form of simplification. Okay, we have various trigonometric identities. Better apply and check how it's possible to get the answer. Below also cos x available. So I'll try to change this sine square into cos. So limit x tends to pi by 3. 3 minus 4 into What is sine square is 1 minus cos square, is it? Sine square is 1 minus cos square over here 2 cos x minus 1. And now see what happened. Now limit x tends to pi by 3. What happened here? 4 cos square x, 4 cos square x minus 1. Check, is it 4 cos square x minus 1 over 2 cos x minus 1. Now you can factorize. You can factorize the numerator a square minus b square pattern. So it becomes easier now. That is 2 cos x minus 1. 2 cos x minus 1 into 2 cos x plus 1, is it? 2 cos x plus 1 over 2 cos x minus 1, right? So it's cancelled. Limit x to 60 degrees or pi by 3. And I apply the pi by 3, get the answer. Put x for pi by 3. Cos pi by 3 half. Okay. Here this cancel. Here cos pi by 3 half. Half times 2 is 1. 1 plus 1, that is 2, right? There's a limit exists. Answer is 2. It's my third video. I target to work many other videos, so similar question hereafter, some exams type problems also. So keep in touch with my YouTube channel. Here I show some, I try to work nearly 75 or 80 questions in this limit revision, as I work 30 problem in vectors, structure, essay, both big problem in vectors. Similar in this limit also.